Hi everyone, my name is Savannah Russo and today I will be explaining problem 14.7 in the solutions chapter, and we will be solving a weight percent problem for both the molality and mole fractions of solute. So our problem states household bleach is a 5.0 weight percent aqueous solution of sodium hypochlorite, also known as NaOCl. What is the molality of the bleach and what is the mole fraction of NaOCl? So what we want to first understand is what a 5 weight percent aqueous solution means. And so what that means is we have our 5 grams of our solute, which is sodium hypochlorite, within 100 grams of solution. We know that this is the case because when you take 5 divided by 100 and then multiply it by 100 again, that gets you 5.0%. So now let's solve the first part of the problem. So we're finding what the molality of the bleach is within the solution. So for molality, we need to find the moles of solute and divide that by kilograms of solvent. First, let's find the moles of solute. So we know we have 5 grams of NaOCl, and if you use the periodic table, you can find that the molecular weight of sodium hypochlorite is 74.439 grams per mole. And if you plug that into your calculator, you'll find that we have 0.0672 moles of NaOCl. Next, we need to find the kilograms of solvent. So we know we have 100 grams of total solution and 5 grams of NaOCl. In order to find the water, we need to just subtract the amount of NaOCl from the total grams of solution, and that gives us 95 grams of H2O. And then in order to find the kilograms, we just divide it by the conversion factor of 1,000 grams per 1 kilogram, and that gives us 0.095 kilograms of H2O. Now we have all the information we need in order to solve for molality, so we can go ahead and plug in our values into the equation. So we have molality equals 0.0672 moles NaOCl over 0.095 kilograms of water. Now just plug that into your calculator and you should get 0.71 molality. Now, on to the second part of the problem. So the second part of the problem, we are finding the mole fraction of NaOCl. And so first let's define what the mole fraction is. The mole fraction is the amount of moles solute divided by the total moles in solution. So we already know the amount of moles from the previous part of the problem when we were solving for molality. So we know that the moles of NaOCl are 0.0672 moles. But we don't know the amount of moles of water. So let's solve for it. We know we have 95 grams of water from when we were solving for molality before. And if you look at your periodic table, you'll see that water's molecular weight is 18.02 grams per mole. And you can plug that into your calculator, and you'll find that we have 5.27 moles of water. Now, we can find the total moles of solution by adding our moles of water and our moles of NaOCl. And if you plug that into your calculator, you'll find that our total amount of moles is 5.34 moles. Now we have all the information we need in order to solve for the mole fraction, so we can go ahead and plug our values in to the equation of the mole fraction. So the moles fraction for NaOCl is the amount of moles of NaOCl, which is 0.0672, over the total moles of solution, which is 5.34 moles. And if you plug that into your calculator, you'll get 0.0013. And this does not have a unit because the moles cancel out. Thank you so much for watching. I hope this helped.